Hey, what's up, guys? This is Chung here again. So this time, LeetCode number 639, Decode ways number 2. Okay. So this one, it's very similar to the Decode ways number 1, right? So, the only difference for this one is that, besides the numbers from 0 to 9, we also have like a wild card, which is a star. But anyway, so basically, we want to decode a string of letters of digits into uh, the mapped in English letter version, right? So basically, so A can be mapped. A maps to 1, B maps to 2, and Z maps to 20, up to 26. Okay, and to decode, if you're given like this kind of a string, right? So we can decode this one into AAJF or KJF, right? But this 1, 11, and 06 is invalid because 6 cannot be represented by 06. It has to be 6, not without leading 0, right? And then, so what's interesting for this problem is that we're also introducing a wildcard. So basically, a wildcard, which is star, can represent any digit from 1 to 9. Okay, keep in mind, so 0 is excluded, which means that this one star cannot represent 0. I didn't notice this part. That's why I got the wrong answer at the beginning, right? So we have to be careful. So it's only from 1 to 9. Uh, yeah, and since the final answer could be large, we do a modular, right? So for example, example 1, if there's a single star, obviously the answer is 9 because it has basically from 1 to 9 without 0, right? Because our numbers, our letters starts from 1, not 0, right? And then 1 star, we have 18, right? So on and so forth, like this one, and then right. So for this one, if I think you guys all know how to do the solve decode ways 1, right? Basically, we're gonna use a DP solution, right? We have a DPI here. Okay, so DPI means that from 0 to I, how many ways we have to decode this string here, right? And at current I here, we do two things, right? So first we check if the ISI, right? So if the ISI is greater than 0, if it is, then we do a DP I plus DP I minus 1, right? So basically we have two scenarios. If the current one is not 0, then it means that we can we can use the current one to as a separate letter. That's why we can just accumulate the previous one, which is dpi I minus 1, right? And then the second one we check, right? Basically, if the s I minus 2 to I is within the range of 10 to 26, right? So if that's the case, right, and then we have another solution. Basically, we can use the current one, the previous one, to represent the letter from 10 to 26, which is I think from J to Z. I think something like that, right? So then we can also accumulate that second version is this, right? DP I minus 2 in this case, right? Basically similar like there's a 1 here, right? So we have some letters beforehand. Let's say we're at here. So first is this one. Basically, we can use this one to represent A. That's the first one, right? And then the second one is that since we also check the previous one and the current one, right? We checked if these two numbers are within the range of 10 to 26, right? This one's 11. It means that we can also decode this two as a letter, single letter. think this one is gonna be K, if I'm not mistaken, right? That's why, once we do this, okay, so first one, if we use the current one as a separate ladder, then of course, right, the previous count will be I minus 1, right? Or if we use these two digits to represent to map a new ladder here, then the previous one, of course, will be dp I minus 2, right? So we just accumulate this all the way down to the end, right? And then we simply return a dp minus 1. That will be our final result. So that's the decode way number 1. But for this one, since we have a wildcard star, right? So we have to consider it separately, So for me, I think I just have like write a bunch of if else statement. Basically, I just consider them separately. The first one is like this one, right? The first one is it's obviously, sorry, it's 1 1, right? So this is the same case as the decode 1, right? And the second one is what? Second one is this one, right? One star, right? Third one, and then we have star 1, right? And the last one is star star. Right, this one can be anything, right? I'm just using one as an example. Right, so basically this is the 4 scenarios we have, right? I believe there could be a way to combine all these things into one like section of code, but I just handle them separately. Okay, so this one we already know, right? So for this one, okay, so if the current one is a star, right, and the previous one is not star, so what does this one means? It means that it means that obviously the current one can be from 1 to 9, right? And then it means that, okay, it means obviously we have dp of I minus 1 times 9 for sure, right? Because if we treat the star as a separate ladder, and we can have like whatever before we have plus 1 to 9. That's why we have dp I minus 1 times 9, right? And then depending on the previous ladder, right, we could have like a few more, right? For example, if we have 1 as a previous digits here, what does it mean? It means that we can also have like 111 to 19, right? Because remember, this one can represent anything, which means that then with this case, we also have like dp of I minus 2 times 9, right? So that's the second part, because with 1 we have this. But if this one is 2, okay, if this one is 2, so what do we have? So first, this one is always valid, right? Depending on what the previous value digit is, the second part could be different. So if this 1, right, if the previous one is 1, because the previous one is 1, we have this, right? If the previous one is 2, we can only have 21 to 26, right? Then what this one mean? It means that we have dp of I minus 2 times 6, right? So this one is dp I minus 2 times 9, right? How about 3? 3 to 9, or 3 to 0? Doesn't really matter, right? So if it's 3, if the previous one is other than 1 or 2, then this part is gone, right? Okay, cool. So that's that, and so that's the first scenario. And how about the second scenario? Right. So the second scenario is this one. So the current one is not 1. Sorry, the current one is is digit, but the previous one is a star. Right, so for this one, obviously we have dp of I minus 1. So it's similar like this one, right? And then plus what? Plus the previous one. So the previous one only has like 2 scenario, like same thing. So the previous one, if you want to include two digits at for this case, the previous one can only be either 1 or 2, right? I think for 1, we will definitely have dp of I minus 2, because if we use the wildcard to represent 1, right, it doesn't really matter our card number. It can always be dp I minus 1, right? And then for second dp I minus 2, which is the case, this one equals 2, then I need to check if the current one, if this one is within 0, is within 0 or 6, right? If that's the case, and then we know, okay, we can use the 2 to represent plot to with this one to represent a valid ladder, right? Okay, and so that's the second one, or you can just always you can always do a for loop of whenever you see a star, you just do a for loop from 1 to 9, right? And then you just basically iterate all the combinations, and then you always check if the ladder is within 10 to 20 to 26. Then if it is, you just increase the count by 1. I'm doing this just to avoid that for loop, to improve the performance a little bit, even though it will not affect the big O, but still it's a 10. If you have 10 times 10 for loop, it's going to be a 100, right? For the case of this one. Okay, back to here, right? So this one is like, if we have 2 stars, so what do we have? 2 stars, of course we have this one, right? So first we have dp of I minus 1 times 9, right? So that's the case of using the second star as a single letter, plus what? Plus dp of what? dp I minus 1, I minus 2 times what? 9 plus 6, right? Because we already know, right? If we want to include these 2 letters, there are only 2 cases that this will work. If if this one is 1, or if this one is 2, right? And we have already calculated that, if when it is 1, we have 9 possible ways. When it is 2, we have 6. So total will be 9 plus 6, right? So that's how I did it. I just analyzed all the different scenarios, and that's it. Cool. I guess, and then we can start coding then. Let's see. We have going to be a length of s dp, right? 0 n plus 1, right? Because I dp 0 equals to 1, right? So because if we have 2 letters, right, like 1 1, right, I mean we do a dp I minus 2, right? So this one, when I is equal to 2, dp 0 should be 1, right? This means that dp 0 equals to 1 means that if it's an empty string, right, if it's empty one, there's nothing, which it means that we have one way of decoding it, which is nothing, right? Basically, this is the base case. Then we have mod equals to 10 to the power of 9 plus 7, right? And then the dp, right? So for in range 1 to n plus 1, right? So the first case is like if the s I minus 1, right, is not equals to star, right? So I check if the int, I think I can do this. If this one is not equal to to 0, right, and then I can do a dp of I equals to dp of I minus 1, right? Or I can do a accumulate. Doesn't really matter. So this is the first step, right? So this is the what? maybe this case, right? It doesn't really matter. This case, maybe. Basically, the current one is not, it's not like a star, right? Maybe two. Yeah, I don't know if I can write a proper example here. The second one is the basically here is only decode, right? Current one, current digits to letter, right? So the second one is decode. Uh, 2 digits, right? To letter, right? So this is the second one. To do that, we have to do a check. Basically, we can only do this if I is greater than 0, greater than 1, right? And then if basically here I'm separating them into 2 scenarios, right? So if the previous one is star, right? So if the previous one is not star, okay? So if it's not star, then that's the that this is the decode 1 base, right? Decode base 1 scenario, right? Which is they're all letters, right? Like 2, 23, something like this, right? So if that's the case, I simply check this one, right? So if that's 2 is within the range of 10 to 26, right? I minus 2 to I to 26, right? Then I just accumulates I to this dp I minus 2, right? So that's decode 1 case. Else this is the wild card case. Basically, it's gonna be a star star 1, a star or star 2, right? So that's the wild card case. So for this one, right, we so first we have dpi plus dp I minus 2. So this is the case of use star as 1, right? So for if we use star as 1, it doesn't really matter what the current value is. It will always be a valid one, right? And then the second one is that if the int of s I minus 1, right, is smaller than 6. If the current one is smaller than 6, then we can also basically accumulate this I plus 2 one more time, right? So this one basically we use star as 2, right? So when we use star as 2, the current one has to be smaller than 6, right? So this is the 2 scenario here, right? Okay, now we have handled all the scenario when the current one is not star. And then else is when the current one is a star, right? When the current one is a star, first we have this, right? So we have I dp of I minus 1 times 9, right? So what does this one mean? It means that this one is means that we use the current one as basically decode current star to letter, right? Which means from A to I think I. Yeah. So basically, this one we decode current star to letter, which is A to I. That's why we have 9 times this, right? And then the second scenario, not a case, is that we have to consider 2 digits, right? Basically similar as the previous one. We have I equals to greater than 1, right? So this one we have this, this one, right, we have, like I said, we have three scenarios here. So the first one is that, if the si minus 2, if the previous one is equal to 1, right? So what does it mean? It means that, we have dpi times dp of I minus 2 times 9, right? So this is the case of 111 to 19, right? Else if si minus 2 is equal to 2, right? So for this one, we have, I can copy and paste this one. This one is 6, right? So this is the 20 to 26, sorry, 21 to 20 to 26. Yeah, so keep in mind, be careful. This is not 20 to 26. I was using 7 here. That's why it gave me a wrong answer, because remember the star can only represent from 1 to 9, does not include 0. That's why this is 21 to 26, not 20. Okay. Else if else if the previous one is a star, right? Then it is just a 9 plus 6, right? Basically, this is like the combination of the first and second case, right? So this is the 11 times 9 plus, right? So that's a combination, because star can represent anything from 1 to 9, and only 1 and 2 can give us some valid decode ways. Okay, that's it, right? I mean, and don't forget to do a modular every time we are finishing the DP, right? And then in the end, return the DP of -1. I think that's it, right? Yeah, I think let's try to run it, see if it works. Okay, this one accepted. If I run it again, cool. So it works, right? Yeah, I think that's it, right? I mean, for time complexity, obviously this one is like O of n time complexity, right? N is 10 to the power of 5, because we're simply doing some like O of 1 calculation here, right? And another way, we have a lot of if else here. I think another way of doing this is that if we don't want to separate these things here, every time we see like a star here, we can always do a for loop. We always do a for loop from 1 to 10, right? So that way we can do some combinations to always check if this one is like, so do something like this. We always check if this one is in the 2 digits is in the range of 10 to 26, right? Basically, we can rewrite this part into some like nested for loop, right? If it's a 2 stars. So for the first one, we have a for loop for 1 to 9, and then we have a second nested for loop for the previous one as a 1 to 9, and then we can just do some comparison, right? I think in that way, I believe we can combine some of this conditions here, right? But I think that condition will be a little bit slower, because we're gonna check some unnecessary combinations, like like 3 3-star, 4-star, and 5-star, those kind of thing. I did it in this way because this way is faster, and we don't have to add that unnecessary for loop then. Anyway, that's how I did, and I guess I'll just stop here. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.